Hi guys. So I just received this question from one of my students, and it happens to be an inequality question that says we should solve 2x minus 4 over x plus 3 is greater than x plus 2 over 2x plus 6. So these types of inequality questions are categorized under rational inequality. As you know, we have quadratic inequalities and we have linear inequalities. But anytime we see the quotient symbol or this divisor, we know that we are having a rational inequality. So it's not so difficult. But now, one common mistake most people make is to go ahead and cross multiply. They will just say cross multiply as they usually do in normal algebra questions, but that would be an error. Why? Because this question is dealing with inequalities and not equation. So if you cross multiply, you are wrong. Now, the first thing we are going to do is to multiply both sides. Let me just write it. We're going to multiply the both sides, by the squares of the denominators. So what are our denominators? Let me just write them. We're referring to x plus 3 and 2x plus 6. These are our denominators. And the reason why we are doing this, the reason why we are multiplying both sides by the squares, the key word there is the squares, is because one inequality rule is that when we multiply or divide an inequality by a negative number, the inequality sign is going to change. Now, we don't want the inequality sign to change. In the case of equation, that law did not hold. So that was why we usually cross multiply without any consequences. But in this case, because we are trying to avoid the inequality sign from changing, because if it change, of course, we have altered the question, and of course, we know that there is now a problem there. That is why we are squaring the denominators before we multiply both sides by them. Because of course, if you have a negative number, if you square it, the negative sign is gone. Like minus 2 squared will give us plus 4. So you get the idea. And once we do the same thing on both sides, the equation is balanced, or the inequality is still balanced. Let me just put it that way. So if I do that, I'm going to have this. I'm going to have 2x minus 4 so I'm multiplying by this and this. I put the square on top so this will not be confusing, into x plus 3 into 2x plus 6 squared is greater than, on the other side we are having x plus 2 into 2x plus 6, this is 6, into x plus 3 squared. So I hope you understand this. So we have 1x plus 3 here, because the denominator here is also x plus 3, so it cuts or it cancels one of the x plus 3 here where there are two. On the other side, or in this case, we have 2x plus 6, because we have 2 here, and one in on the denominator cancelled out 1, so we are left with 1. So that is why we are arriving at this. So if I want to simplify further, I noticed something. Of course, I can just do it to avoid any confusion. I'll bring everything here to this side, so that we were going to factorize, because well, we have to factorize before we find the solutions, the roots. So, but of course, the root is not going to be one specific number as in equations. It's going to be a range. So I'm going to be having 2x minus 4. Just going to rewrite everything we have on this side. 2x plus 6 squared minus everything here, because when it comes to this side their sign will change, so I'll just put them in one bracket. X plus 2, 2x plus 6, x plus 3 all squared. Everything is greater than 0. Alright, so we have something like this. Good. So what next is, we are going to look at this and factor out. There's something common just to make our process simpler. I noticed that on this side I'm having 2x plus 6, and on this I'm also having 2x plus 6. I'm also having x plus 3, and I'm having x plus 3 here. So I'll pick it out. I'll pick those expressions out, those linear functions, as a common factor. So I bring them out and I say x plus 3 into 2x plus 6. So this is like already two factors that I'm having. Then I open my bracket and write out my remaining factors. So if I simplify here, I'm having x plus 3 into, this is one factor, so into 2x minus 4, because I'm using these factors to divide this and this. What remains is what I'm writing inside. So it's like your simple factorization technique. So I'm having 2x minus 4 multiplied by 2x plus 6. Remember that we have 2 here, so this will divide this. When this divides, 1 is left, minus on this side. When this divides this, we are left with, okay, x plus 2 and 1 of this, because this will cancel one of that, x plus 3, all greater than 0, we still have our sign there. Good. So what next? We'll simplify what is inside here. So meaning that we have x plus 3, 2x plus 6. If I want to simplify, I'm going to first expand this. I will expand this and expand this, and that will, yeah, I'm having 4x squared. This is 12 minus 8, which is positive 4, positive 4x, if I'm not mistaken. I'm having 12 minus 8, positive 4x. On this side I have minus 24, minus on this side I have what? This is x squared plus 5x plus 6, all greater than 0. And I will simplify now. Maybe x plus 3, just going to write this, plus 6. So if I simplify, don't forget, okay, if I open my bracket, everything here becomes negative. So I'll say 4x squared minus x squared will give me 3x squared. Okay, cool. Then I have 4x minus 5x giving me negative x. That's negative 1x, which is 6x. And I'm having minus 24 minus 6, which is giving me minus 30, all greater than 0. You see what we are trying to do with, we are trying to simplify because of what we did here. Factoring this out, it makes the work easier. Because if we said we want to multiply all this, some people will just go ahead and say, okay, multiply everything here, and that we're expanding three linear functions, which of course is going to give us a cubic function with the power of 3. On this side, the same thing, no problem. But simplifying that, we know that it will take time. This times this times this, so it will take time definitely. So but this is much faster compared to that. So, and if as you can see, we have a quadratic function here. This quadratic function, of course, can be, this one's already linear factors. This quadratic factors function can be factorized into two linear factors. And to factorize that, the first thing, okay, we'll just say 3 times minus 30 will give us minus 90. So we are looking for two factors that when we multiply them, we'll get minus 90. And when we add them, we are going to get the middle term, which is minus 1. So, and those two factors happen to be, okay, I think 9 and 10 can work. We should be having minus 10 and plus 9 will give us negative 1. And minus 10 times plus 9 will give us negative 90. So that is a simple factorization technique. If you can drop in the comment section your a request if you want to know how to factorize. There are different techniques. So I'm going to have on this side 3x, I will say plus 9x minus 10x minus 30. I'm just writing it again so that it will not look as if I'm skipping too much steps. So when I factorize this now, 1, 2, I will group, factorizing by grouping. I'm going to have x plus 3, okay, cool, 2x plus 6. And on this side, 3 is common, as we can see. 3x, in fact, 3x is common. So I'm going to have 3x plus 3, because when you bring 3x out, you have here, so this will be 3x plus 3, just say 3x plus 3 into 3x into x, 3x into x plus 3, cool. Then on this side, I can see that minus 10 is common. So I have minus 10 into x plus 3. So I don't want to skip too much step. That's why I'm going in details. So we are done with that. Now we just have x plus 3 into 2x plus 6. Okay, then on this side we have 3x minus 10. 3x minus 10 into x plus 3, all greater than 0. So we have 4 factors, but if you look at these 4 factors very well, you see that, this, and this are the same thing. Yes, because x plus 3 and x plus 3, of course, that's, you can write this as x plus 3 squared. But when you look at this one carefully, when you can still factorize this as 2 into x plus 3. So we can just say we have 2 into x plus 3, 2 into x plus 3 times x plus 3 squared into another 3x minus 10, all greater than 0. So once we have this is the key to actually just solve our inequality question, because the question is saying we should look for a range. If it was an equation question, this is where we'll stop. We are finished, no problem. But since we are dealing with inequality, we are going to use a one of the methods that we already know, that since our root is between x is equal to minus 3, of course, x is equal to minus 3, or x is equal to 10, positive 10 over 3. Since these are our roots, it means our possible range will be, if I draw a number line just to be clear, our possible range is either in this direction, or in this direction, or in this middle direction. So anything in this direction is greater than, x is greater than 10 over 3. Anything in this, my left side, is actually x is less than minus 3. Anything here in the middle is minus 3 less than x, which is less than 10 over 3. So I'm going to use that to find my answer. If I'm going to pick out possible numbers, you can just guess any number, but the guess must be between this range. Anything greater than 10 over 3, I'm going to use 4. Anything less than minus 3, I'm going to use minus 4. And anything in between minus 3 and this is 3.3, I'm going to use 0. So I put 0. So when we do that, we are going to know our answer. I'm just going to draw a short small table like this and say, okay, this is where this is minus 4, this is 0, and this is 4. So if I try 4, I'm going to I'll substitute minus 4 in this expression, or you can say in this equation, and see whether I'm going to get a number greater than 0 or less than 0, because it can either be greater or less. Good. So minus 4, of course, minus 4 into, we can forget about this 2 because the 2 does not actually affect, does not affect the sign. Minus 4 plus 3 is giving me a negative sign. So negative 1, let's say, minus 4 plus 3 here is also giving me a negative sign. So negative times negative is positive. So we have positive here. What about here? This is 3 times minus 4 is giving me minus 12. So that is negative. So this is negative actually. So we'll say negative. Let's see. Okay, let's do that. Let's do that again. We have minus 4. Minus 4 plus 3 is giving me negative 1. So we have negative 1. Minus 4 plus 3 here is also giving me negative 1. But if we square it, it's positive. So this is negative actually. Okay, cool. So if this is negative and this is negative, when we multiply, we get positive. So this is actually positive. 0. If we put 0 here, we have 3, which is positive. This is also 3 positive. Okay, good. This is negative. So this is negative. So if this one is positive and this one is negative, what about this one? If you put 4 here, you have 7, which is positive. Here you have 7 squared positive. Here you have positive as well. So this is also positive. So our answer is either between this range or this range. So what I'm just going to say, I'm going to say x, the solutions are x is less than minus 3 or x is greater than 10 over 3. This is my final answer.